limits. So the first one we're going to look at is the limit as x approaches 0. Yep, great. The blue boxes are back. Of sine x over x. So can I get you guys to type sine x over x into your calculator in radian mode? You can press zoom trig to get it to show up. We're going to look at the graph. Now this trig function doesn't work currently if I do direct substitution, because if I direct substitute, I'm going to have a 0 in the denominator, right? So it crushes it immediately. So when you put sine x over x, what is it approaching from the left and the right? One, right? The graph is approaching 1. So what we could do, let's pay attention. If our calculators were stolen from our fingertips, what we could do is we could use function notation and operation. That is not straight. Operations of functions in 30-1. It's probably, oh, that's worse. Good. I'm going to do this. Okay. Oh, great. Cool. Cool, cool, cool. Okay, your sine x graph goes based off of your unit circle. We agree? So it starts at 0, 0. And then, what the heck? And then at pi over 2, what's it at? Let's go less. At 30, or pi over 6. What's sine at pi over 6? 1/2. And then, what is going on? And then pi over 3, which is 60, it's at like 0.87, blah, 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 blah. Stop it. And then at pi over 2, it's at what? 1. And it's like a little glimpse, right? Then here, at negative pi over 6, it would be at negative 0.5, negative pi over 3, 0.8660, and then negative pi over 2 would be down to negative 1. So we have a sine graph that looks something like that, around 0, correct? I don't need the whole graph because I'm literally asking for the limit around 0. We agree? So I'm doing a very little glimpse for around 0, the sine x graph. So this is the graph y equals sine x. The other function we're looking at is just x, correct? Our numerator is sine x, our denominator is x. So that's 0, 0, and then what? And then 1, 1, negative. Anyways, it's just a small, it looks like this. We agree? So if we wanted values on either side of it, our problem is that at 0, if I do f divided by g, if this is like f of x and this is g of x, I'm going to get 0 over 0, correct? And that's where we get that open dot on the graph that you see in front of your face, right? Now, we have the graph y equals x, that's this one, yes? So technically, if I wanted a point that was close to it, they're going to end up getting closer and closer to 1, and then they come and do some spinning around. Because what you're going to end up doing is you're going to take like something here. Let's say we take pi over 6. Let's pretend we have that. We would end up doing 0.5. So if we did, the function was f of x equals sine x over x, correct? If we did pi over 6, this would be 0.5 divided by pi over 6. Because you put it in for x's, right? We would get f of pi over 6 equals sine of pi over 6 divided by pi over 6. We agree? So that would be 0.5 and then pi over 6. Type that in. Your calculator. 0.5 divided by pi over 6. What are you getting? Pardon?
0.95.
0.95. So it's coming up here, right? It's about here. Well, if we want closer, instead of using pi over 6, what could we use? Something really close to 0. What's really close to 0? 0 decimal 0, 0, 0, 0, 1, something like that. We just can't use 0 because 0 is going to kibosh us. It's going to make us go right to not working. So if I go 0 decimal 0, 0, 0, 1, that's really close on the right, correct? Really tight to the right of that 0. Do we agree? And if I went negative 0 decimal 0, 0, 0, 0, 1, it would get really tight to the left of it. But we want to be in radian mode, guys. Sine of 0 decimal 0, 0, 0, 1 divided by 0 decimal 0, 0, 0, 1. Make sure you're in radian mode. Type it in. What do we get? 0.999999999, which is really, really close to 1. Guess what, when you put in the negative 0.0001 is going to happen? You're going to get really, really close to 1. Therefore, the limit as x approaches 0 of sine x over x equals what? 1. So the great thing about that is if I'm ever given a limit as x approaches 0 and I can get it into the format of sine x over x, I can just replace that with a 1. Because this is true. We just showed it, right? Can you guys, instead of putting sine x over x, could you put sine 5x over 5x into your calculator? Sine 5x over 5x into your y equals? What are you getting? Samesies, right? You're getting the same thing. It's getting still going closer and closer to 1, correct? On both sides of it. Sine 5x over 5x. Make sure you close your bracket on the 5x. So it doesn't matter if you put a coefficient in front of it. It just has to be the same coefficient in the denominator, and it'll still approach 1. We agree? Okay. So, example 1. I really love when it does the blue boxes. Determine the limit as x approaches 0 of sine 5x over 4x. It has to approach 0 because we can, the reason why I put the graph in your calculator is so that you can actually visualize what this graph is doing, right? As it's approaching 0, it's getting closer and closer to 1, correct? It also is the reason why we picked 0 is because 0 is going to cause us to have that point discontinuity, that gap where the graphing can exist, right? If I picked anything else, you could just plug in a value and you get a value. So that one's not a problem. So if I look at this one, though, I have sine 5x over 4x. What do I need it to be over? 5x, right? So I know that if I can get this sine 5x over 5x, that will just become 1. Do you agree? Because that's the limit. So what could I do? Well, I could technically multiply the denominator by 5. But what I do to a denominator, I have to do to the numerator. I'm going to put a 5. And then I'm going to get, I'm going to rearrange it. I'm going to get the limit as x approaches 0 of 5 times sine 5x. What's the rule about multiplying things? Can I move around the order? Or do I have to leave it as 5 times 4 times x? Can I rearrange it? Can I put the 5 by the x? Is 2 times 3 not the same as 3 times 2? Is 2 times 3 times 4 not the same as 4 times 3 times 2? Yes. So, I'm going to rearrange it so that the 5 is with the x and the 4 is not. You know what I'm saying? So I'm going to write it as 4 times 5x. You see how I just rearranged that? We agree? Now, with multiplication, if I have two separate fractions, I multiply numerator times numerator, denominator times denominator, correct? So if I have two separate fractions, I can make them a full fraction. We agree? If I have a full fraction, can I not make it two separate fractions multiplied, technically? So I can rewrite this as the limit as x approaches 0 of 5 over 4 times sine 5x over 5x. If you're questioning if what you did is illegal, if you just math it, it should go back to what it was, correct? So if I put the numerator times numerator, I get 5 sine x. If I do denominator times denominator, I get 4 times 5x. So what I did was not illegal, right? And as the limit as x approaches 0 of sine 5x over 5x, what does that become? 1. So this is going to become a big old 1, correct? And then is my problem gone? My problem was that x in the denominator, and it's gone. So now I have 5 over 4, technically times 1, which is 5 over 4. Does that kind of make sense? So our goal when we have signs is to try and get whatever is beside that sign in the denominator with an x, and then they can cancel and become 1 if it's approaching 0. So, new example, example 2. The limit as x goes to 0 of sine 6x over sine 5x. So my hint to you is the sine 6x has to be over 6x, and the sine 5x has to be over 5x, and you have to get that to happen. Try it out. That's my hint. We'll see where you're at. So this equals the limit as x goes to 0. I know I need sine 6x to be over 6x. We agree? Can I just randomly multiply a denominator by 6x and just leave it there? Say we're done? No. I have to also multiply the numerator by 6x. And the reason why is, what is 6x divided by 6x? 1. And if I multiply by 1, am I changing anything? No. So I know the denominator needs the 6x, then my numerator needs the 6x, because 6x divided by 6x is 1. Yes? Okay. Samesies for the bottom. So, then I get sine 5x over 5x. And what do I need for the top? If I put a 5x in the bottom, I need to have a 5x in its numerator, because 5x divided by 5x is 1. I'm not changing the ballgame here. Correct? Everyone following along with me? Now, some people might say, well, don't I have to multiply every numerator and every denominator by it? Well, no, because technically stacked fractions can be written side by side, correct? And then you wouldn't be multiplying every numerator and every denominator. So, sine 6x divided by 6x, this turns into a 1. Sine 5x divided by 5x, that turns into a 1. And then I'm left with the limit as x approaches 0 of 6x over 5x. What happens now? If I plug a 0 in, I'm in trouble. What can I do? Take an x out. Just cancel them off. It's a monomial and a monomial, right? If it was like 6 plus x and 5 plus x, I'd be in trouble. I would not be able to do it. But because it's a monomial, these cancel off, and I'm left with 6 over 5. So I'm going to have you try 2 of them instead of doing them out of your book. Because this textbook doesn't really like the trig limits like that, but you need to have them. So the textbook doesn't really have questions. So these are 2 homework questions. They don't need to appear in your homework up for Friday or anything. These are just on here. Okay? And then I'm going to give you another type that's a little bit different. So this is 1 and 2. 1 is the limit as x approaches 0 of sine 2x over 3x. And then this one is going to be the limit as x approaches 0 of sine x over x squared plus 3x. Go away. Sine 2x. What does it have to be over in order for us to put a 1 in? 2x. So it already has the x. We just need the 2. Oh, good. 2 and 2. So we're going to get the limit as x goes to 0 of 2 over 3 times sine 2x over 2x. We can rearrange it. That becomes a 1. And so my answer is 2/3. This one, I have to GCF out of x. It's actually easier than that one. The limit as x goes to 0 of sine x over x plus 3. And I can rewrite it to make it easier to see what's going to happen if you'd like. I can go sine x over x times 1 over x plus 3, right? True statement? This turns to a 1, and then I can sub in. I get 1 over 0 plus 3, which is? 1 over 3. 1 over 3. Yeah? Okay, here's your challenger. Limit as x approaches 0 of tan 2x tan 2x over 3x. Remember the problem is not if I ended up with a cos x. Because a cos anything x would become cos 0, correct? And cos of 0 is actually 1. That is not a problem, right? So if I'm left with a cos on my denominator, I'm totally fine. I just can't be left with a sine. My hint to you is we still have to use the rule of sine 5x over 5x gives me 1. And tans can be turned into what? Sine over cos. Try it out. And this little xex needs to get out of our life because it's ruining it currently. We can't plug in anything. And then I'll give you 3 other questions after this, and then when you're done, you're done. So we would get the limit as x approaches 0 of sine 2x over cos 2x, technically divided by 3x if I so chose. Technically, right? Dividing by 3x is the same as multiplying by 1 over 3x. So I have the x. So I could technically go and rearrange these however I so chose, right? They're all being multiplied. So I can go the limit as x goes to 0 of sine 2x over x, and then I can split that into 1 over, and make the 3 join the cos 2x. Problem child still not gone. I need to multiply this by what? 2, because I need to get a 2x down here. So multiply that by 2, multiply this top by 2. We agree? This becomes a 1, and then I'm left with a 2 on the top, over 3, and I can plug a 0 into a cos in the denominator. I just can't plug a 0 into a sine in the denominator, because sine of 0 is 0, which ruins it, correct? But cos of 0 is 1, so that's totally fine. So I'm going to get cos of 2 times 0, which means cos of 0. So this turns to a 1, and so I get 2 over 3. Do you agree?